When it comes to space, new objects and phenomena are being discovered almost every day, and some are quite frankly incredible. All-time top brings you the top 10 most mind-blowing things in space. At number 10 we have space lightning. In 2011, a group of scientists from the University of Toronto, Canada, discovered an electrical current travelling through space, comprising roughly 10 to the 18 power amps, or over 1 trillion of our lightning bolts down here on Earth. The lightning bolt is thought to have originated from a giant black hole at the centre of the 3C303 galaxy. The black hole's enormous gravitational pull allows it to fire up this impressive lightning through gas and dust up to roughly 150,000 light years away. Just picture a lightning bolt 1.5 times the size of our galaxy and you're pretty much there. At number 9 we have the Diamond Planet. And when it comes to planets, some are admittedly cooler than others. Planets made of ice, planets made of lava, but none really compare to 55 Cancri E, a planet which is thought to be over 30% solid diamond. Once a star in a binary system, its partner began to devour it. Cancri E was not able to pull away its carbon core, and so with plenty of heat and pressure being applied, it eventually transformed into the shiny beast it is today. At number 8 we have neutrinos. So neutrinos are these subatomic particles, which means they are really small. So small in fact that they have very little interaction with matter itself, which makes them incredibly hard to detect. A typical neutrino will travel through many light years of matter before it interacts with anything at all. However, with very large and very sensitive machines, like the one in the Sudbury Neutrino Observatory, scientists are able to detect around 30 neutrinos per day, of the trillion or so that come through, allowing us to study and maybe one day figure out the mystery of these elusive little particles. At number 7 we have the Large Quasar Group. Now, from one of the smallest things in the universe to one of the largest, the Large Quasar Group is a huge, or large, group of quasars that by all known logic and math should not even exist. Our galaxy, the Milky Way, is 100,000 light years across. Pretty big, but not when you compare it to the Large Quasar Group, which stands at a gargantuan 4 billion light years. Modern astrophysics states that the maximum size any cosmic structure should be able to reach is around 1.2 billion light years, so as of yet, scientists have absolutely no idea how a structure this large even formed. At number 6 we have Galactic Cannibalism, which sounds more gruesome than it really is. Galactic cannibalism occurs when an entire galaxy collides with another. The smaller of the two usually takes most of the damage, but this is not always the case. Sometimes the two merge with little to no conflict, normally when both galaxies are very equal in terms of size and speed. A lot of the time, however, stars collide, planets collide, and galactic clouds collide, creating the perfect environments and events responsible for the creation of new stars. I mean, I'm impressed. At number 5 we have Antimatter. Antimatter, as you may have guessed from the name, is simply the opposite of matter. A positron, anti, and an electron, regular, is a simple example of the two. The same spin, the same mass, but opposite charges. And when both of these come into contact, they are converted into pure energy, i.e. a large bang. Antihydrogen, the simplest antiatom, has been created in certain lab experiments. The problem, however, is containing and utilizing these, as the mere contact with air would result in the annihilation of both the anti and regular particles. It is thought that there was, at the birth of the universe, an equal amount of both anti and regular matter. This would logically suggest total annihilation, as each regular particle would inevitably collide with each antiparticle, and boom. Yet here we are. Puzzling. At number 4 we have gravitational waves. So let's imagine space as a large trampoline. When objects are placed on it, it creates a dip. When heavier objects are placed on it, it creates an even larger dip. This is gravity. Now imagine the space between us was stretched or squeezed. We wouldn't notice because the things we use to measure distance would also be stretched or squeezed. Everything is relative, except light. You see, light always travels at a constant speed. And so if space is stretched, light will take longer to get from point A to point B, and through that we can observe gravitational waves. Now, these waves are normally created when two huge objects, such as large stars or black holes, orbit each other, and they send out ripples of gravitation at the speed of light, distorting everything they pass by. Think of it as ripples in a pool, except instead of splashing you, they mess with the fabric of space-time for you and everything around you. Slightly concerning. At number 3 we have dark energy. If you were to label two boxes, things that exist and things that don't, dark energy would reside in the space between the two. It exists because, well, theoretically it has to exist, but we've never actually observed it. You see, with the amount of sheer gravitational pull within the universe, it shouldn't actually be expanding, especially not exponentially at the rate it is. This mysterious energy that keeps the universe expanding, even against its own gravitational pull, was aptly named dark energy. It seems to be inherent in space itself, and as the rate of the expansion of the universe is increasing with time, it is slowly overpowering our number 2 entry. Dark matter. Now, dark matter, as with dark energy, was conceived as a necessary hypothetical when scientists did the big number crunch and determined that there simply wasn't enough observable matter in our galaxy to account for the sheer gravity holding it together. If we punched in all the numbers for every bit of matter we know to exist, the known galaxies should, in theory, fly apart, and yet they don't. Hence, dark matter. Between dark matter and dark energy, they comprise upwards of 95% of the force in the universe, well and truly showing how very little we know about the true nature of existence. And finally, at number 1 we have black holes. Due to a black hole's immense gravity, when light travels into a black hole, it can't actually escape, hence why we see them as black and why we can't observe them directly. Instead, we can observe them by monitoring stars and gas nearby, ones affected by the black hole's immense gravity. Black holes are formed when a very large star dies and collapses in on itself. It pulls itself into itself and creates a compact, super dense body we call a black hole. A supermassive black hole is a black hole with a mass of more than 1 million of our suns, and several studies have shown that at the center of every galaxy, including our own, there is a supermassive black hole that the entire galaxy is orbiting around. And in case you're worried about nearby black holes floating by and chomping us up, you have nothing to fear. There are no black holes close enough to our solar system for Earth to fall into. That being said, if our sun was replaced with a black hole of equal mass, the planets in our solar system would not get sucked in, but would continue to orbit around it as if nothing had happened. Apart from all life on Earth dying due to the extreme drop in temperature, but that's a story for another day. So that is it for our list of the most mind-blowing objects and events in space. If you enjoyed it, feel free to leave a like, and comment below with what lists you'd like to see in the future. I have been Connor, and from everyone here at All Time Top, have a great day.